This video is looking at section logs h of the logarithms module. Let's start with the logarithmic equations. Equations containing a logarithmic expression, okay, so a logarithm and an expression containing a variable, are known as logarithmic equations. Exponential equations have a variable and an exponent of one or more expressions. So let's look at the difference between logarithmic equations and exponential equations. So you'll notice in each of these ones, there are logs, whereas in each of the exponential ones, there are exponentials. Pretty straightforward there. For simple exponential and logarithmic equations, the definition of logarithms can be used to convert between forms and hence solve the equations. So it's important to remember that bases of logarithms must be positive. Okay, so that's very important, otherwise you might not get a solution. So let's look at some examples. Here we have solve for x. So e to the 4x equals 7. Now if I rearrange this and rewrite it as a log, I get 4x equals ln of 7. Okay, so that's just using our rearranging of a log law. Remembering that that was when a of n equals x, that log a of x equals n. So that's all I've done. So here you can see I've got a natural log, so my base is e, just like that. So I could have written this, if that helps you, as log of the base e of 7. Okay, so my base is staying the same, the 4x comes here, and the 7 goes with the log. So that's all I've done. Now that helps because what I can do now is write, well, x equals ln of 7 divided by 4. I'm just getting x on its own by getting rid of that 4. I'm dividing both sides by the 4. Now that's something that we can plug in to our calculator. If on our calculator we plug in ln, or natural log of 7, and we divide it by 4, our answer should be approximately 0.4865. I've done that to 4 decimal places to try and be a little bit more accurate. Okay, so we've been able to solve for that x. In the next one, 3 to the power of 2x plus 1 equals 20. Again, let's rewrite it as a log. So I can bring that 2x plus 1 and I can write that as log 3 of 20. Okay, so basically whenever you want to find an unknown that's an exponential, rearrange it into a log. Okay, that's the best way of doing it. So from here, I want to get that x on its own, so I need to get rid of that plus 1. So I just take 1 from both sides. So now I have 2x equals log 3 of 20, take 1. I now still need to get x on its own, so I need to divide both sides by 2. So I get x equals log 3 of 20 minus 1, all divided by 2. Now if I want to evaluate this, then I need to rearrange this log 3 of 20 so I can evaluate it on my calculator. So log 3 of 20 can be written as log of 20 over log of 3. Okay, so plugging that in onto my calculator, I have log of 20 divided by log of 3 equals, I'm going to subtract 1 and I'm going to divide that whole thing by 2, and I get, again, it should be approximately 0.8634 to 4 decimal places. Okay, so we're just rearranging our exponential into a logarithm. You do that every time you want to find an unknown that's in a power. Let's look at some more. In this one here, I actually have a log. It's not an exponential. So log 4 of x take 2 equals 3. Now, when you're starting with a log, if I rearrange this, if I go the other way and rewrite it as an exponential, I get x take 2 equals 4 to the power of 3. Okay, so again, I've just rearranged that log. So I'm using the a to the n equals x, then log a of x equals n. That's all I'm doing. Okay, I want to get x on its own, so I'm going to add 2 to both sides. So I end up with x equals, now 4 to the power of 3 is 64, so 64 plus 2, and that's 66. Okay, next one. Now I don't have this log on its own at the moment, I have this 2 in the front, so if I divide both sides by 2, I'll end up with a log on its own. So ln of x plus 4 equals 6 divided by 2 is 3. Now I can rearrange it into my exponential. So I end up with x plus 4 equals e to the power of 3. I have to get that x on its own, so I need to get rid of that plus 4, so I take 4 from both sides. So now I have x equals e to the 3, take 4. I can then go to my calculator, it's going to be an approximate answer, and plug that in. So find that exponential button on your calculator, the little e. Sometimes it's on top of the natural log, and you have to use your shift or second function button to get there. So e to the power of 3 minus 4 is approximately 16.0855. Okay. Next one, log x of 9 equals 2. Rearranging, 9 equals x squared. Okay. To get rid of that squared on this side, put both sides to the power of a half, because 2 times a half is 1, so you end up with that x. 9 to the power of a half is simply the square root of 9 equals x, so x equals 3. Okay, now note, some of you may have from here to here gone, well, if x squared equals 9, then x could equal plus or minus the square root of 9 because of this squared, and you learnt that in transition maths 1. But the reason why it is only the positive answer is we can't have this negative, the square root of 9. Okay, because the base of our log here must be positive. Okay, so that base must be positive. So that's why I only have the positive answer here. Okay. Now, it may be necessary to use the properties of logarithms to combine one or more logarithmic expressions into a single logarithm to solve the equation. What I mean by that is in these ones here, you had a single log, so we could easily solve it. In this one, you can see we have 2 logs. So my first step is to say, okay, these 2 logs are being added, so I can combine them by putting in a multiplication. Okay, when we add 2 logs, it's multiplying into 1, and then that equals 2. From there, I rearrange, remembering that this is a base 10 here. Okay, so what I have now is that x bracket x take 15 equals 10 to the power of 2. Expand here, x squared minus 15x equals 100. Get the 100 over to the other side by minusing from both sides. X squared minus 15x minus 100 equals 0. I can now factorise, whichever method you like to use for factorising. You end up with x take 20, x plus 5 equals 0. From there, x take 20 equals 0, x equals 20, x plus 5 equals 0, x equals negative 5. But x can't be a negative number. We can only take the log of a positive number. And if you see up here, that's just log of x. So we can't have log of negative 5. Okay? So, but can't take log of a negative. Therefore, x equals 20. Okay, so always remember that in the end. If there are logarithmic expressions on both sides of the equation, the following property can be used. So what you can see here, I have a log base a here and a log base a there. So that means that this x must just equal y. It may also be necessary to use other logarithmic properties to combine expressions, so there is at most one single logarithmic expression on each side of the equation. Also note, check solutions to ensure base values and logarithm values are always positive real numbers. Okay, just like that previous one where we could only have one of the answers. So let's look at some examples here. You can see in this question here, the log base 2 matches, so that just means that 2x take 1 must equal x. Okay, so from there I'm going to add 1 to both sides because I need to get x on its own. So I have 2x equals x plus 1. I then take x from both sides and I end up with x equaling 1. Again, if I plugged 1 in here, I'd get 2 times 1 is 2, 2 take 1 is 1. So that works, it's positive. Here I also have a positive. Okay, so that's what I mean by checking. Another one, a natural log of x plus 1 equals natural log of x plus 1. Now again, see how we have something here that's not a log? So I need to try and make it a log. And the best way to make a 1 into a log is to change it to ln of e. Okay, remembering that log to the base e of e equals 1. Okay, so from there I can now combine these two logs on this side. We're adding, so I can rewrite it as ln of ex. So e is being multiplied by x. Now the natural logs match, so I can say, well, x plus 1 must equal ex. Okay, I want those x's on their own, so I need to get them on the one side together, so I can do that. So 1 equals e to the x take x. To isolate that x, I factorise. Okay, there's an x in both of these, so I bring it out the front. So x bracket e take 1. Okay, I can now divide by that e take 1, and I end up 1 divided by e take 1 equals x. And that's my answer. I can plug that into the calculator. I'm going to get rid of this so I can fit it. If I plug in 1 divided by, now remember to put in a bracket around the exponential. Okay, so exponential 1 take 1 bracket. So you have to have that bracket around it. And your answer ends up being approximately 0.5820. Okay, so make sure you can do these. Again, pause the video, try it yourself, watch it, then pause the video, then do it yourself. Okay, you really need to be learning from this. Okay, in the next question we have 2 logs over here, so I need to make that 1 log. We have a plus in the middle, so it's going to be log of 2x plus 3 x minus 2. Okay, another thing to make this easier, I can take that 2 from here and put it as a power. Okay, so now you can see I have this log here and log there, so they match. So I can now say that that x squared has to equal 2x plus 3 times x minus 2. I can now expand the right hand side, and I get 2x times x, 2x squared, 2x times negative 2, negative 4x, 3 times x plus 3x, 3 times negative 2 is negative 6. So now I've got x squared equals 2x squared minus 4x plus x, it's just minus x minus 6. I'm going to take that x squared over to the other side, so I'm going to take x squared from both sides. So I end up with x squared take x takes 6. I can now factorise that. And from there, x take 3 equals 0, x equals 3, x plus 2 equals 0, x equals negative 2. Okay, if I came back up here, you can see how that x is on its own, so I can't have negative 2 as my answer. So, but x can't be negative, therefore x equals 3. And if you look in these ones, 3 take 2 is 1, so that's positive. 2 times 3 is 6, 6 plus, so that's positive as well. Okay, so that works. What now? There are lots of questions for you to practice, and that's under Logs H1 in the textbook. Again, remember this is tricky. This is the hard stuff of logs, so make sure you go over it, make sure you understand it.